Okay, so let's just start the second session. Green is the new black, understanding and managing resources. The first talk is by Lluc Canals and Adrian Schiffer, and it's called The Purpose of Modeling Electric Vehicles Batteries.
Well, when we think about electric cars, it's like science fiction, like, okay, maybe you're talking about Back to the Future or something like that, but maybe not.
Well, in fact, the electric vehicle was already developed simultaneously with the combustion engine vehicles. As you can see, in '86, it was the first patent from Daimler-Benz of an automobile. But in '82 was already the second electric vehicle, which was already quite similar to this, supposed to be the first automotive. And it was actually developed in France by Adrian. Then there's like the next problem with this electric vehicles is it's useless if you can't drive. It's like really, like a PhD student without coffee is like useless, we can't concentrate. And what we really need is to know how much coffee is still in the vehicle. And we have to be able to forecast the behavior of the battery. Because otherwise we will have the situation that most people already know with the mobile phone. You have the charge is full, it shows 100% and 70, but suddenly the phone is dead. And it's most times because of the use cases are wrong chosen. And for this we have to exactly modelize to avoid burns of the of notebooks, mobile phones, which are most times also because of false use of the charger, but also to avoid the burn of the car. In this case, a Tesla Model S, which burned the last year with 3 others, but basically it's still more secure than a combustion engine. And for this purpose, and for this to avoid to burn down all the batteries, because they're very expensive for the automobile sector, they start with 4,000 euros, they have no ending of the price. They're like the more expensive one are 50,000, but they can also cost 20,000, 30,000. It depends what the manufacturer wants to do. And it's just very ineffective to test so many batteries to find the failures in the system. And for this kind, there are models. On the left side, you see the DFN model. It's a chemistry model which needs like more or less between 100 and 140 parameters, depending on the extension you add to the model. You get very precise forecasts about how the model works, but it needs a lot of resources. Also, like to find out the parameters, they're very difficult to measure. It starts with particle sizes, transition speeds, whatever. And for the manufacturer, most time the equivalent circuit is much easier to use and to measure. Even if they're like, you see now, they're like 250 parameters. But if you want to simulate also the charging behavior, it's already 500 parameters. But they're still good to measure. You can optimize it with parameter estimation parameters. And you can also, it's quite modular. You can improve the thermal behavior. You can make aging. You can simulate damages. You can do whatever. And you can make a small battery the same as a big battery of thousands of cells like Tesla does. And that's very important for the car manufacturer because at the end, they just want to earn money in an effective way. Hopefully not like Walter White from Breaking Bad with drug money, but for them, it's not effective to build batteries for 50,000 euros to just destroy them or to make tests that they don't work or they don't work out for this model and the use case of the driver. And for example, in Volkswagen, they have a lab which costs 20 million euros just before testing. It's just to have the machines there worth 20 million euros to test 15 batteries, nothing more. It's very costly. And for this, it's very ineffective if they just burn down the batteries.
So as he was saying, as Adrian was saying, car manufacturers want to earn money. And that's what they search. They don't really want to build cars because it's funny. They have a business to run. And the electric vehicle nowadays, not as much of a business. They are losing money each time they sell a vehicle, and they are losing money each time they send a battery to recycle. So what did they thought? They thought, oh, maybe you can do something with the batteries between the end of life on an electric vehicle and before recycling. Because a battery is considered not to be useful for traction services when it has lost 20% of its capacity. So it has still an 80% of it. So it's plenty of energy to be used in different ways. And they thought, OK, if we use it again, we can save some money, put it back into the electric vehicle, make the electric vehicle most affordable, and maybe we can do something about that. So when you're trying to sell something that's second-hand, the first thing that the buyer is going to ask is, OK, and how much time this is going to last? Is it going to last 1 year, 2 years, 3 years, maybe 6? And the car manufacturers right now is like saying, have no idea. I don't know. So they thought maybe we can just investigate a little bit on that and try to understand the behaviors of this thing. So back again, we can see that the physical explanation of the aging processes on batteries are like there are plenty of things happening, mix it all around between them. So we have a complete chaos. It's like a tie that almost impossible to really model and try to do something with that. So instead of trying to investigate into these physical parameters and things, what we do is take from these huge batteries that Adrian was talking about, just a small cell, and we test it and we age it in accelerated modes. Different conditions, laboratory testing equipment, etc. And we see what these cells are behaving, how are they behaving. And we take some mathematic models of this behavior, taking just temperature, voltage, and things like that, which are much simple. Then again, we have to think about how are these batteries going to work in this second life application, right? So when we have the behavior and how are they be working, we can put them, all this, into this simple model that Adrian told you about, all this mixed up, and we do some, like, it's the moment of magic, right? Taking the rabbit out of the hat. We run the model, we wait, and we see. And we see, and if the lifetime of the battery is long enough to provide some profit, we'll have a happy car manufacturer. And by the way, we'll have our thesis finished, which would be good. Well, thank you very much.